A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, instructor for the course NPTEL MOOC course Pavement Construction and Technology, funded by Ministry of Education, Government of India. Today's lecture will be under the lecture 4 under the module 2 on unbound courses and their functions. At the very beginning, I would like to acknowledge the use of text, informations, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. Now we discussed about the flexible payment component. There in the previous lectures we discussed about the subgrade course, its functions, its characteristics. Now the course which is followed conventionally in the construction of flexible payment after subgrade construction are your unbound granular courses. So you can see this is a flexible payment structure, where at the bottom we have the compacted subgrade which is there. Over that particular one we have these granular courses which are granular base or granular subbase courses. The one which come immediately above your subgrade, compacted subgrade, is called as subbase course. Now we call them as unbound courses because traditionally we don't use any binding material. We will discuss also certain courses which are used with some binding material also, but the conventional practice is no binding material is used in the granular courses, and that is why the name is given as unbound courses. So the unbound courses are typically the subbase course and the base course of a flexible payment. So what the two courses which comes over the subgrade, which is without any binding material, are the immediate one is your subbase and followed by the one over it is your base courses. And the mixes which are used or the courses which are used as unbound courses consist of the granular subbase course, this is one course, water-bound macadam course, cement treated subbase course. As I mentioned, this is there we can use a material as a subbase course which is having a binding material also. Here cement is the binding material, so or fly ash or any pozzolanic material, then it becomes cement treated subbase courses. Then we have wet mix macadam. So this is also an unbound course usually used as a base courses. Then in base courses we can again have the cement treated base courses. So this is again a cement treated base course. So these are four quite common quite common courses which are used under your subbase courses and base courses in the construction of flexible payments. Coming first to the granular subbase course, here I will show you this is a cross section of a flexible payment structure. Here you can see this particular part is your compacted subgrade. Over this particular one there is a course which is constructed. This is the course which is constructed. You can see this is the course which is there, and this is your granular course, granular subbase course. Now the granular subbase course construction consists of laying and compacted well graded material on a prepared subgrade. So well prepared subgrade, whenever this course has to come up, this subgrade has to be well compacted and ready for the construction of a granular course. This granular course can be constructed in single layer or in multiple layers depending upon the requirements. The requirements are in terms of the load which is going to come, the design traffic which is going to come, or it may be in terms of the functional requirements. This granular course plays a very important role, especially in terms of the drainage of a flexible payment structure. Whenever we talk about a flexible payment structure, one parameter is very important, that is your drainage. So and this drainage is not only what we are talking about the surface drainage. When we say that the surface drainage, on the top whatever surface course or wearing course we will construct should be dense enough so that any water which falls over it with the help of the camber goes to the side and with the slope gets collected in whatever side trenches we construct. So your surface should be dense enough. but there are chances that there may be some infiltration of water which may take place, and that infiltration of water may be because there may be some presence of cracks may be there. In due course of service life of the pavement, some cracks may arise, and which can allow the infiltration of water from the top surface, or the earthen shoulders are there on the sides, so the water may percolate down, and that may allow the intrusion from the sides. And there may be, in case of high water table, the water may make your subgrade also saturated. So different conditions can arise which can lead to intrusion of water in your pavement structure also. Now, if pavement structure there is some intrusion of water, we should give a dedicated path for the water to get out of the pavement structure. If it has entered because of one or the other reason, then there should be a provision which allows that water to move out of the pavement structure, and that is what we are going to do with the use of these granular subbase courses. So the material to be laid is in one or more layers as subbase or a lower. If I am doing the construction in terms of two layers, the lower layer will be called as lower subbase and the upper subbase as necessary according to lines, grades and cross sections. Definitely whatever camber we are going to have, that camber we are going to start from the subgrade layers itself, and as we go up, this camber or closed slope will be followed in the upper layers also. So the cross section elements are to be followed from the subgrade itself, and it goes up. If the thickness of the subbase layer provided in the design permits, the subbase layer shall have two layers, the drainage layer and the filter layer. Now, this is as per the requirements of IRC 37, which is there for the design of flexible pavements. And the other, as I mentioned, the other important reference for all these road construction related works is our MOR inch specifications. Now, what two things which are important is if I want a layer to serve the purpose of drainage, any water which comes from any region from the top, or any water which is coming from your subgrade, I want it to move out of my pavement structure, then I will provide a layer with a high permeability or a good drainage characteristics. And here you can see I have extended this particular one, and I have provided this drain at the edges of my pavement structure, or it can be made extended up to the edges so that water goes out of it and gets collected in your side drains. In both the cases, we can see that this particular layer is specially designed. Specially designed means the gradation which is to be selected, the construction which is to be done should be in such a manner that it allows the water to move through it, and then it gets collected in the side drains, and you have these pipes which are going to take it to the nearby culverts or other water outlet facilities. Now, when this is to be there, this is to be an open gradation. Now, the subgrade soil which is there can get intruded into these granular courses. If it enters into a granular courses, then it reduces the drainage capability or the permeability of these granular courses. So, normally whenever these granular courses are constructed, they are constructed into two layers. The bottom one is known as a filtration layer or a separation layer. It separates your drainage layer from your subgrade material, so that it does not allow any intrusion of your finers into that granular material, so as to lead to any reduction in the drainage capability of it. And then the upper one can come up as your drainage layer. So, I will always prefer to construct my granular subbase courses in two layers. The bottom one will be considered as a separation and a filtration layer, and the upper one will be considered as a drainage layer. Now, in certain cases, there may be some restrictions related to the crust thickness. So, there can be a possibility that only one layer of a granular subbase course is to be constructed. Then in that case, that layer has to serve both the purposes, your filtration or separation along with your drainage purpose. So, that along also we need to select a proper gradation so that it can be acting as a filtration layer. Otherwise, when we construct in two layers, filtration layer or a separation layer has a low permeability, allows the water to a lower extent to drain out compared to what you give through your drainage layers. The upper layer of the subbase functions as a drainage layer to drain away any water that possibly enters through the surface cracks, not only through the surface cracks from your side shoulders. As we have seen, the formation width is there where you have your earthen shoulders also. So, it may enter from your earthen shoulders also if they are not constructed good enough, or there may be high water table which may have occurred. Usually, we always say that the bottom of your subgrade should be at least 1.5 meter above your high flood level. But then also in certain cases, if some chances of intrusion of water takes place, then this subbase course should allow the water to move out of your pavement course. Otherwise, if the water is present in your subgrade or in your subbase or any other courses, it will lead to a reduction in the strength of that particular course. When it is there, bituminous bounded courses, we will discuss later. The top bituminous bounded courses are there, and if water stays in these courses, it will result into the loss of strength because of the loss of bond between the aggregate and the binder. And when it comes to the granular courses, they lose, or the subgrade, they lose the strength in the presence of water. If this happens, your subgrade, if the strength is lost, subgrade will get highly stressed, and there may be permanent residual deformation which can happen in your subgrade, leading to rutting or the distortion leading to rutting failures in your flexible pavement structures. The lower layer of the subbase functions as filter or separation layer, as I mentioned, to prevent intrusion of subgrade soil into the pavement course especially. The filter and drainage layers, now we have specific guidelines to look into how these layers are to be individually designed. Like the filter and drainage layers are designed as per SP 42 requirements, guidelines for road drainage, SP 50, this is guidelines on urban drainage, and this is SP 20, which gives you the, because simultaneously the drainage aspects related to the rural roads also has to be looked on. So, SP 20 takes care of it. For effective drainage, both the filter and drainage layers must be extended to the entire width of the embankment slope. This is very important. If I do not have these drains at the edges, this entire has to be extended to the edges. Otherwise, you can see on the top, if you see on the top, the bounded courses are extended up to this one only. But when it comes to your granular courses specifically, they are extended to the pavement edges. This is your shoulder and this. So, they should be daylighted so that water, it moves through it, this side and this side comes out of it. So, this is important aspect. The material to be used for the granular subbase shall preferably, now different material combinations can be used. It is a granular material. So, what it says, natural sand can be used, crushed gravels can be used, crushed stone can be used, crushed slag can be used, or a combination depending upon the gradation required, because MORTH specification gives 6 gradations for a material to be used in subbase courses. I will show you in the upcoming slide. Use of materials like brick, metal, concrete, crushed concrete shall be permitted in the lower subbase courses only, not in upper subbase course, because of it has to serve the purpose of drainage also. In addition to this one, where the situations are challenging and where you want a better control nowadays, use of synthetic geotextiles or geosynthetics are also becoming more or more popular. So, commercially available synthetic geocomposites, grid cell geolock with perforated vertical faces filled with aggregates meeting the requirements, and for this particular one for the use of geosynthetics we refer to SP 59 guidelines for use of geosynthetics in road pavements and associated work. So, here you can see these are geocells where you fill up the granular material. So, they will serve two purposes for us. They will serve the purposes of drainage layer. So, it serves the, because these are perforated ones. So, it allows the water to move through it. Secondly, this will add to the strength of your pavement structure also, because it will do the purpose of your reinforcement also. So, geosynthetics serves the purpose of your drainage layer also, your filter layer also, and in addition to this particular one, it gives a good reinforcement also. So, here this, but specifically in this particular reference, we are mentioning it for the use of the drainage purpose. So, if you want to enhance the drainage of a particular course, you may make use of the combinations of these geosynthetics along with your granular courses for construction of a drainage layer. As I mentioned, MORTH specifications gives 6 different gradings, grading 1 to 6. Now, all these have, depending upon their requirements, have where it needs to be used. It has given 6 gradings. Different gradings can be used for different purposes and for different layer thicknesses. Whenever a layer thickness is to be considered, we always say that the layer thickness should be 2.5 times of their NMS, nominal maximum aggregate size. Now, this nominal maximum aggregate size is again a size where we say that the material should be whatever NMS we recommend. It says that NMS is, if I do any aggregate gradation, I will come later on also, if I do any aggregate gradation, say this is C1, C2, C3, C4, C5, if I do any gradation analysis and I work out the cumulative percentage passing. So, this is my cumulative percentage passing 1, cumulative percentage passing 2, cumulative percentage passing 3. So, this is for 1, 2, 3 and this is for 4. Now, here the size which will be on the top, obviously I will have 100% passing material, and there may be a sieve at the bottom ones where I may have very small material, may say 0 to 3% cumulative percentage passing through it. So, this NMS says it is the size where at least 10% of the material is retained. So, it is the, so in that this is one sieve. If I have any particular size S3 which can form, so a sieve size which at least allows some material to pass over it. So, there are 2 definitions which is normally referred for NMS. One says it is the first sieve size over which at least 10% material. So, if one size is there where 10% material is passing, so first sieve size in the range where some 0 to 10% material is passing. So, this is for NMS. We will come up to this discussion of NMS again in later slides for other mixes also, where I will show you some gradations and I will show you some NMS also, just to give a reference about it. So, it says the grading to be adopted for a project has to be specified in the contract. It always which grading is to be used in lower subbase and the upper subbase courses. We prefer to use for a drainage course normally gradings like 6s. This is quite often used for making a drainage course in flexible payments. Now, the other, as I mentioned, that the other aspect which we need to check is, you can see this is the granular subbase course which is extended up to the daylighted edges. So, whatever waters which comes through any this particular upper course through any cracks should move through this one, because it gets an easy path for its removal and gets move out and get collected to the side drains. So, there are few definitions or requirements which are there. If a single filter cum drainage layer is to be constructed, it says 150 mm. 2 requirements which are there as per IRC 37 says that at least a drainage as well as filter layer minimum 100 mm thickness should be there. And if as I said, in certain cases, if you do not have a good thickness of subbase course available with you, you have to do the construction of some separation as well as filter as well as drainage layer in one course only. So, then in that case minimum 150 mm thickness is to be there. And MORTH says whenever you construct, it is better when you construct a subbase course in 2 layers, go with at least 150 mm each layer, 150 mm in each layer. So, it is advisable if you go for subbase course construction in 2 layers, then preferably 150 mm. And as I said that at least 2.5 times the nominal maximum size of aggregates is to be used as the layer thickness. So, if NMS of a particular gradation is say 19 mm, then it should be 19 into 2.5 should be there. So, around I can say the layer thickness should be 50 mm. So, 50 mm should be the minimum, the depending upon, but this is not the NMS of the gradations which are available. You have NMS larger than this particular one. So, and it says on the other hand, it says that the layer thickness should be at least 100 mm minimum, but if I am constructing in 2 layers, I will prefer to construct each layer of 150 mm. The total thickness of the granular subbase course should be adequate to carry the construction traffic. Now, even another important aspect is when you construct a granular subbase course, the construction vehicle will come up, they will compact the course. You need to ensure that the material which you are using in granular subbase course should not get over compacted, otherwise the drainage capability of that particular layer will get reduced, or the material should be good enough to bear the load which is going to come from the construction material. Otherwise, its gradation changes, it breaks down, gradation changes, and it does not serve. So, we need to ensure, and the subgrade should be strong enough to take this granular subbase course material, and it should not get over stressed by during the laying and compaction of the granular subbase course. So, all these factors need to be taken care while you are designing your subbase courses. So, that is why it says this thickness requirement may be worked out to satisfy the subgrade rutting limiting strain criteria, because when we discussed about the flexible pavement failure, we discussed that 2 parameters we will consider. One is the strain at the top of your subgrade courses, and the second is the tensile, this is the compressive strain at the top of your subgrade, which is the rutting criteria, and the other important part is the tensile strain at the bottom of your bituminous courses. Now, as I mentioned, the typical type of courses which are used in subbase or base construction, one is the waterborne macadam, the other we discussed was the granular subbase course where 6 gradations are there. The second typically which is available in your IRC 19 and MORTH specifications is waterborne macadam. Here the word says it is a macadam, it is a combination of aggregates which is bounded by water. So, it consists of clean crushed coarse aggregates mechanically interlocked by rolling and voids thereof filled with. So, here we choose a aggregate gradation, and where coarser aggregate particles are taken up, they are laid, compacted, and then we add some fines which are known as screenings to this particular, again compacted, and this gives you a good granular course for upcoming courses of a flexible pavement. So, here it says that by rolling and voids thereon filled with screening, and in some cases we put some binding material also over the top of the screening also with the assistance of water, and that is why we call it as waterborne macadam. And this is IRC 19 which gives the standard specifications and code of practice for waterborne macadam. Nowadays not very popular in the construction of flexible pavements. Instead of it, wet mix macadam, which we will discuss in the upcoming slides, is getting more popular because of few challenges specifically related to its performance. The binding material to be used for WMM as a filler, usually filler is the material which passes around 75 to 100% of it will pass through a 75 micron sieve. So, that material is known as filler, where any material whose 75 to 100% passes through this 75 micron sieve during gradation is represented as filler. This is a conventional terminology we use. Coarse aggregates which are greater to sizes of 2.36 mm, fine aggregates which are in the range of 2.36 mm, 275 micron, these are fine aggregates. Anything which is below 75 micron is your fillers. So, it says that what materials to be used in the case of if you put a binding material also, it says passing 100% through a 425 micron sieve and possessing plasticity index value of 4 to 8 when the WMM is used as a surfacing course and less than 6 when it is adopted. Normally in flexible pavement construction, only in some earlier days with the earthen surfaces or granular surfaces only, when waterbound macadam used to form a surface course, then we used to have the binding material which used to have some amount of plasticity. So, the plasticity index value was in the range of 4 to 8, whereas otherwise if it is used as a granular subbase course, the plasticity index should be restricted less than 6. This is important aspect. Otherwise, its water holding capacity increases and that may lead to the damage of your flexible pavement section. Now, the coarse aggregates, as I mentioned, there is a coarse aggregate and then screenings and then a requirement of binding material. So, two gradations are given for your this coarse aggregate part. One you can see for a size ranging from 63 to 45 mm. This is again the size ranging from 53 to 22.4 mm. This specifically, so two size ranges are mentioned here for coarse aggregates, may be used as a subbase and a base course or a surface course, not a flexible pavement. It will not form a surface course. As I said, only few, when earlier roads were there, some earthen roads were there which were surfaced by this waterbound macadam. The coarse aggregate shall conform to one of the gradings given in table 409 of MORTS 2013. So, this is the coarse aggregate gradation. And then as I mentioned, once the coarse aggregate are compacted, you put the fines over it. Two gradings are given for the fines which are your screenings. So, two gradations for screening material is also given. So, then these screening material is put over your rolled coarse aggregate and then again compacted with the use of water. So, screenings to fill in the coarse aggregate shall be generally of the same material as coarse aggregate. However, economic considerations, non-plastic materials such as concrete and moram or gravel other than river-bound material can also be used. So, but with due permission, and where, as I mentioned, the important aspect is that the plasticity index value should be less than 6. Now, these are unbound courses. This is a waterbound course and the granular subbase course. If I use some binding material which may be a fly ash, which may be a cement or any other pozzolanic material, lime can be used, then it becomes, it normally comes under the category of cement treated subbase courses. So, this is another part which says that the materials used for cementitious treated subbase shall consist of soil, riverbed materials, natural gravel aggregates, reclaimed. I can use aggregates from different sources, crushed aggregates or soil aggregate, modified with different cementitious materials such as cement, lime, fly ash, etc. So, if I am using any cementitious material along with these different kind of aggregates, then it becomes my cement treated subbase courses. So, the one important requirement, if you are doing the cement treated subbase course construction, then the minimum thickness should be at least 200 mm. And it says that since it is a cement treated one, there is a requirement in terms of strength also. The strength should be at least 1.5 to 3 megapascal. This is another requirement. Unconfined compressive strength of the cement treated subbase courses should be of in this particular range. The gradation also, as the 6 gradations which were mentioned in the MORTS, out of which it says that for cement treated subbase courses you use the gradation 4 for making up these cement treated subbase courses. Now, the other popular granular course which is used in flexible pavements, very popular, it is wet mix macadam, and it is used as your base courses. Now, it is normally either if you are using a waterbound macadam as a subbase, then you need to follow up with your wet mix macadam as a base course. Even if you are using a granular subbase course, then also it is followed by wet mix macadam as a base course. And these material requirements and characterization we will discuss in upcoming modules also. So, it says that clean, crushed, graded aggregates, granular material, coarse, sand, etc. are to be used, and finally compacted to get a good, this is shows. So, at a proper water content and a gradation, the WMM material has to be compacted to achieve a desired strength along with the requirement of your cross slopes. And there is a requirement that the thickness should not be less than 75 mm. Because the gradation which is adopted, and it can go maximum up to 250 mm. The gradation which is recommended by MORTS is shown here. We have from 53% at least, so 100% material should pass on it. As I mentioned, NMS is the one size over the sieve size which have at least 10% material passing. So, or I can say it is the size where at least some material pass. So, for this particular case, the NMS will be 45 mm, or this is the material, this is the sieve size where at least 10% material will be retained, because here either 40% material will be retained or 20% material. So, one sieve size over this particular one where at least 10% material is retained is your NMS. The other definition which is popular is the first sieve where some material is retained. So, then it makes 45 as your NMS. So, these are the gradations which are available. The IRC 109 specifies how the practice has to be done using the wet waste macadam. And again here also it is specified that this material which is finer than 425 micron in this particular gradation shall not have a PI value less than 6. So, these are some of the general considerations of the materials to be used in your granular courses. We will further discuss in the next lecture about the functions of these granular courses. Thank you.